Okay, so in this problem we are finding the points at which, points rather, at which the graph of the equation has a vertical or horizontal tangent line. Okay, so you're starting with the 9x squared plus 25y squared plus 144x plus 150y plus 576, why am I laughing, is equal to 0. And what you'll have to do with this when you have two different variables is you'll have to differentiate implicitly, meaning that when you differentiate you're going to be doing it with respect from one variable to another. The x's will be fine on its own. You'll just take d over dx of those particular values, but the y's you'll have to differentiate dy over dx. So in this case right here, once you've taken the derivative, I've just set it up and telling you what I'm going to do here. Take the derivative of this one right here. You'll have 18x after you started with 9x squared. 25y squared will leave you with 50y dy dx. 144x, 144, and 150y will leave you with a positive 150 dy dx. And of course the derivative of 0 is simply 0. And now at this point I'm just going to algebraically manipulate the equation so that I get my dy dx all on one side. And so I'll divide by 50y plus 150. And I'll also move the 18x and the 144 over too as well, making these negative as they enter the other side. So dy dx ends up being negative 18x plus, minus 144 over 50y plus 150. Now I can simplify this by dividing everything by 2 right here, and it would leave me with an equivalent equation. Okay, so now at this point I'll tell you now that horizontal tangent lines will be found where dy dx is equal to 0. Vertical tangent lines, on the other hand, will be where dy dx is undefined. And so to find out where your horizontal tangent lines are, I'll start with this side. I'm going to factor out a 9 and leave the expression x plus 8 in parentheses over here, and I'll set that equal to 0, in which x would be equal to negative 8, and that's the value that you'll get to make that 0. And overall, to make that dy over dx equal 0. Same thing with the vertical tangent lines over here, except this one right here, to make this undefined, you would need this y value right here after I factored out the 25 to be negative 3. And this whole equation right here will be undefined when y is equal to negative 3. And so from this point on, I'm just algebraically going through this here and solving for y over here and solving for x on this other side. It's a whole lot of adding and multiplying. It's a lot of big numbers, but it all works out really, really nicely. So I'm left with 25y squared plus 150 is equal to 0. And I can factor out 25y here, leaving me with a y plus 6 on the inside. So y can either be 0 right here, or y could also be negative 6 as my possible values for the horizontal tangent lines over here. And on the other side over here, once this is set to 0, I can factor out a 9, leaving with x squared plus 16x plus 39, which factors very nicely. You're left with x plus 13 times x plus 3. And when you figure out which ones make that 0, you plug in a negative 13 there. That'll make that 1 0. And x could also possibly be negative 3 on this side, and that would make that 1 0 as well. So, using the values that you have up here and here, this, for example, negative 8 is going to be the x value for both of the horizontal tangent lines right over here, and the values that you found, y equals 0 and y equals negative 6, are going to be your y values respectively over here for your horizontal tangent lines. X equaling negative 13 and negative 3 are going to be your x values for the vertical tangent lines, and as found earlier, y is equal to negative 3, and that's what makes that one undefined. So your vertical tangent lines are as follows: negative 13